Session number 3, question number 1. If 4 times A subtract 7 greater than number 9, which of the following cannot be equal to A? From this inequality, we have 4A greater than 7 at 9, it is 16, or A greater than 16 divided by 4, it is number 4. So number 3, option A, it cannot be equal to A. Question number 2. First, we can easily recognize that 27 it is number 3 raised to the power number 3. Hence, we have s over number 2 equal to number 3, or s equal to 6. The option D. Question number 3. First, we cancel variable y in both sides, and next we move the number 7 from the left side to the right hand side. Then we have k equal to -2 subtract 7, that is -9. Option D. These 3 questions, they are very easy. Question number 4. Is rather difficult. Which of the following figures could not be formed when the cone shown below is intersected with a plane? We can imagine that the cone like a cake, and the plane like a knife, and we use the knife to cut the cake. We will check every option. Option A. It is a can be. It can be happen. Let me draw a cake like this, and if we put the knife in the position, it is a horizontal, the plane like this, and option A can be happen. Option B. It can be happen if we put our knife with an angle like this, the cake like this, and if we put our knife with an angle like this, and B, option B can be happen. Frankly, option C, it cannot be happen. But to be sure, we will check the option D and option E. Option D, it can be happen if we put our knife next to the cake. We try to use a different color. We put our knife like this, tangent to the cone. And option E, it can be happen when we put our knife vertical to the cone like this. And we can get the figure like this. The final result is option C. Question number 5. A complete network of size n is n points connected by line segments. What is the minimum number of segments that must be removed from a complete network of size number 5 so that one point has no segments connected to it? That means we need to isolate a point. We will try to the first case when that we check a complete network of size number 2 with the point A and the point B. To isolate the point A, we just need to erase the segment AB. And that means with a complete network of size number 2, we need to remove just one segment. We will try to the complete network of size number 3. We consider the triangle ABC. For example, if we want to isolate the point B, we need to erase the segment AB and the segment BC. And that means with a complete network of size number 3, we need to remove 2 segments. To be sure, at this time we can guess, but to be sure, we will check the complete network of size number 4. We will draw the rectangular step by step. A, B, C, D. There are 4 points. For example, if we want to isolate the point C, we need to erase 1, 2, and 3. That means with a complete network of size number 4, we need to remove 3 segments. And that means with a complete network of size number 5, we need to remove 4 segments, option D. Question number 6. 75% of n is 45. 45. Any what percent of 90? From this, we have 0.75 n equals to 45. That means n equal to 45 divided by 0.75. So the first we use a calculator is 45 over 0.75, that is city. And n is what percent of 90? It is simple. We just take 60 over 90 equal to number 2 over number 3. Number 2 over number 3, and we times 100 to change to percent. It is 66.66. It must be option E. Question number 7. The figure is made up of a square and 4 congruent triangles. 4 congruent triangles, that means they are equal. The height of each triangle is half the base. What is the probability that a point in the figure picked at random will be inside a shaded area? To find the probability, we just calculate the area. This is geometric probability. We need to calculate the sum of 4 areas of 4 triangles, and divided by the areas, total areas. We consider this triangle. We from the question we know that the height is half the base. Then we fold it into the square. We erase this and do the same to this triangle. We have this one, this one. That means there is a sum of arrays of 4 triangles equal to the area of the square, and then the probability is 1/2. Option A. Question number 8. A even and B odd. Which is odd? A at B, it must be odd, because we know that even at odd, it must be odd. A times B, it must be even. B raised to the power of A. We take A equal to number 2 and B equal to number 3. Then number 3 raised to the power of 3 squared will be equal to number 9. It is also odd. Then this one is okay. This one is okay. Option D. Question number 9. A translation in the SY coordinate plane follows. For every positive horizontal move, that means as 4, there is a positive vertical move. It is a y of number 2, starting up at the point 5, 7. The translation goes to x 31. What is the value of s? From the question, we know that the point 5, 7 translate to the point x 31, and that means the change in the vertical direction is 31 subtract 7 equal to 24. The change of vertical direction that is x vertical, no, it is a y coordinate. Y coordinate that is a number 2, and that means there must be 24 divided by number 2 equal to 12 steps. And if we want to find the change of horizontal move, we just take 12 times 4, that is 48, and then s equal to 5 at 48, that is 53, option E. Question number 10. This question is funny. It is easy. There are two ways to finish this question. The first way, we just take s equal to minus number 3, and then put it into the function. We have 29 subtract 24 add 15 equal to 0. In the bottom we have this number 2, and the final result is option C. The second way is useful when if we want to have a different way, a different point of view. We factorize the top can be factor s square at a times x at 15 equal to this. We cancel x at number 5, and we have the function. It is x at number 3, and of course the final result is also 0.